water by a group of fixtures. Design loads of a pipe serving a group of plumbing fixtures will depend not only on the number and type of fixtures installed, but on the operation of the fixtures. So let's now move on to the main topic, the water supply pipe design methods. We have four methods. Method 1 is simple empirical design method. Method 2 is the WSFU, or the water supply fixture unit design table method. And method 3 is the velocity design method. And method 4 is the equal friction design method. Method 1. Simple empirical design method. In the empirical design method, piping is sized with rules of thumb based on the observation and experience. For example, the mains that serve fixture branches can be sized as follows. Up to 3 1/2 inch branches can be served by 3/4 inch main. Up to 3 3/4 inch branches or up to 6 1/2 inch branches can be served by a 1 inch main. Up to 5 3/4 inch branches or up to 10 1/2 inch branches can be served by a 1 1/4 inch main. The empirical approach is used in the design plumbing system for residence and similar building with simple plumbing system. Branch pipes can be sized from minimum branch requirements cited in the building code, such as those provided in table 13.7. So here in table 13.7, supply branch size and water supply fixture unit load requirements of common plumbing fixtures is shown. So in this table, there are different types of plumbing fixtures, and it has a corresponding minimum branch pipe size. And of course, a water supply fixture unit load, or the WSFU. The second method is WSFU design table method, and WSFU stands for water supply fixture unit. To do this method, we have to follow the following steps. First is to obtain the minimum service water pressure for the location of construction. Usually, this is available through the municipal water department. And then next, compute the total WSFUs, including proposed and projected future plumbing fixture. 3. Calculate the maximum developed length of water piping, the actual length of pipe between the source of supply and the most remote fixture plus the developed length of fittings. Developed length can be approximated by multiplying the actual length to the most remote fixtures by 1.2 to compensate for the loss of meter and fittings. Next, compute the static head and subtract it from the service water pressure. Then, use table 13.10 to determine the water and distribution pipe sizing based on the total demand in WSFUs, maximum developed length of water piping, and the supply pressure. Ito naman yung table 13.5 na tinutukoy dun sa step 5, kung saan dito titignan yung sizing ng pipe at saka yung length. So we have sample problem here. Using the WSFU design table method, determine the minimum meter and distribution pipe sizes. Assume the following. Minimum service water pressure for to the location is 65 psi. Total WSF use is 28. Actual length of the pipe between the source of supply and the most remote fixture is 83 feet, and the elevation above the source of supply is 23 feet. So first, we have to obtain the minimum service water pressure for the location of construction. In this problem, given naman siya, so we have 65 psi. And then, step 2 is to compute the total WSF use. And we have 28 in this problem, given siya. At kapag hindi siya given, makikita natin to dun sa table 13.7, yung pinakita ko kanina. And then, step 3 is to calculate the maximum length of the water pipe. So, we have here in a 83 feet actual length of pipe. Imumultiply lang natin siya sa 1.2 based dun sa step 3. And then, makakakuha na tayo ng 99.6 feet, which is approximately 100 feet. And then, step 4 is to compute the static head and subtract it from the water service. So, para makuha natin yung static head, gagamitin lang natin yung formula niya. So, negative 0.433, imumultiply lang natin siya dun sa elevation, which is 23 feet. At makakakuha na tayo ng negative 9.96 psi or approximately negative 10 psi. And then, para ma-obtain naman natin yung supply pressure, isusubtract lang natin yung nakuha nating static head dun sa service water pressure. So, 65 psi minus 10 psi is equals to 55 psi. And then, yung last steps, gagamitin natin yung table 13.10, yung pinakita ko kanina, at ititrace lang natin doon gamit itong mga information na na-compute natin. And by looking at the table, yung makukuha nating meter and straight service pipe size is 3/4 inch, and the building supply and branch pipe size is 1 inch.